Hello, everyone, and welcome to the May 6th webinar between Opto 22 and True Data Ops. Here with me today, we'll go with the first part pretty quickly because we're recording this webinar and we want to hop right to it. So a little bit quickly about who Opto 22 is. We've been in the industry for over 50 years, shipped over 100 million physical I/O points worldwide, over 10,000 customers all over the world, and we're really famous for our lifetime warranty. In that, people know us for rugged control, for our I/O systems, our open protocol use, open architecture philosophy, and how with us, you really have the lowest risk of hardware, lowest risk in when you're using hardware for any of your applications, which are numerous. But of course, today we're focusing on facilities management. So with that, we know who Opto 22 is. Maybe something that you didn't know is that 70% of all Fortune 100 companies use Opto 22 in one way or another. We're manufacturer of relays, older programmable automation controllers, and of course the Epics and the Rios, which we'll be talking a lot about here today. So I'm going to quickly hand it over to Alex, but first just wanted to explain that today's webinar is a really easy one to collaborate on because Opto 22 focuses on the hardware, the reliability, and True Data Ops, TDO, focuses on incredible software, facilities know-how, and an incredible way to deliver it, which you'll be able to see here as we talk about two specific examples, one being McDonald's and one being a 23-story building in Boston, Massachusetts. So with that, I'm going to explain who's joining us here today. We have Alessandro Agnello, PhD. He's the CEO and founder of True Data Ops, and he's going to be taking us here on a journey explaining a couple of those two case studies that we just spoke of, as well as why he's using Opto 22 and why these facilities managers are coming to him and getting the service from him on being able to manage every type of different asset you can think of, from HVAC unit to a freezer to a boiler to looking at a myriad of different assets. So with that, I'm going to hand it over to Alex to explain where he is part of this architecture. Here's our Opto 22 Rio and all the physical devices that we're connected to. And here is Alex now that I'm going to hand it over to. I'm going to stop sharing and hand it over to him for him to introduce himself and talk about True Data Ops and how it can help you in your facilities monitoring and control. Go ahead, Alex.
Thank you. Let me just get quickly set up over here. All right. So I'm Alex, founder of True Data Ops. We've been in operation since about 2019 or so, and slowly but surely growing every day. So brief introduction of what is True Data Ops is we typically have about 7 main modules, from work order management to asset management, and asset management is extremely important. So we're going to hang out in this slide for a little while, to predictive maintenance, why I probably got a lot of your interest on this call to say, oh, I'm really interested in predictive maintenance, some of these creative ideas that we can do with it, along with the energy management, which you're going to see some live demos with today, as we talked about with McDonald's, and then BMS BAS integration, pulling from BACnet, Allen Bradley, you kind of name it, and then IoT integration, and that would be things like the vibration sensor, like I've got one over here if you can see me on my screen.
Oh, great.
Or I got another one right here. I work with a bunch of them, to custom analytics and KPIs. And what we're going to find, hopefully, throughout this class is that when we're talking through, you're going to realize real quick that no two organizations work the same. Could be the exact same footprint, doing the exact same thing. Could be 2 different schools of the exact same size. They're going to run completely different. We've seen it time and time over again. But the one thing that we've noticed looking at, being nationwide, is that when we're going through looking to collect any type of information, adding sensors, we always have to find out what is that asset. So asset management is by far the most important thing. When we're talking, let's talk about the McDonald's here for a little bit. When Rene and I were working through that, one of the first questions I asked Rene was like, I know there's going to be energy management, but could you tell me all the information about the RTU or RTUs they're connected to? I was like, I need to know the manufacturer and the model. Everything else, our system will populate. because we're going to look at that and obviously, and I'm sorry, and additionally, the commission date. We know the location physically. So our system takes this data in and starts building up kind of like a profile of that asset to understand what's happening within it. With our work order system, this is what tells us, hey, someone's complained about this thing. Are they doing preventive maintenance on it? When was the last time it was inspected? Hey, what's the air filters that needs to be replaced with? All this information, you're kind of like, well, I don't see so much the relationship yet. But as we start digging into the details to say, well, no, it really does matter, because if I can correlate the last time it was inspected or maintained versus the energy usage, and I start seeing a spike, I could be like, well, the last time it was maintained was 3 months ago. Because I know it's a manufacturer of X, the user manual says they say we have to replace it every 3 months. It's actually due for inspection. So why don't we generate a preventive maintenance for them to accomplish? All based off just looking at energy data. Seems really crazy, right? Seems like a real crazy idea, but it works because we're using physics and how these things are supposed to do. But the only way to do it properly is to understand your environment top down. What is it? Well, what is McDonald's? It's a restaurant. What is that? What is that RTU hooked up to? There's 3 of them that we're onto. Well, this one's going into the kitchen. Okay, so we know it's going to have a lot of heavy load because we know they generate a lot of heat and they're trying to constantly trying to cool that area, right? So throughout that process, when we were working through, we actually found out to say, okay, well, we had some hypotheses saying that we believe that the kitchen is going to generate the most energy. Then second followed by the dining area. Then third, kind of the outside areas. When you first walk in, that little throughway, the restrooms and stuff like that. Lo and behold, we were right. How much we were right in terms of scale, that's something we couldn't guess. So that's where these emus, if he's got one in his hand, oh, if Rene
can have them close.
Yeah.
It's get stuck. Well, I have to unplug it now. There we go.
Yeah. So having a device like that really comes into handy because from an ROI standpoint, if you have all this data, we can tell you that your asset is going to fail ahead of time. And I'm going to share some of this data later on. With that 23 unit building in Boston, we were using vibration sensors, like the one you guys can see my screen or not with that. We put these on the pumps, and they were chilled water pumps, and we let them run. We were waiting about 3 weeks. We installed it, and then we had to wait about 3 weeks for the data of the internet to come available for it. But in that time, using a Rio and these devices, we were able to build a profile of how these pumps were performing. And with that profile, we realized really quickly, within about 48 hours or so, that one of the pumps was showing actual wear, that it needed to be serviced, but our device was trying to communicate it out, but it had no means to. Okay, until we got that internet connection. So the moment it got internet connection, we set up our alerts that I would get a phone call on it. And lo and behold, I got a call. What did I do? I turned around and I called the facility manager and I said, hey, you're not going to believe it. This device is going to fail. You better go service it. I was like, I know we're really early on and I wasn't expecting this, but hey, this is what happens, right? Other parts of this too, like let's keep talking about the pumps a little bit more, is with the BMS and the BAS integration. So if there's a VFD hooked up to this pump, which chances are it is, if it speaks BACnet or something else that's non-proprietary, we'll pull that information in addition with it. So now we can look at the VFD speed to say, hey, this is how fast it's running, and this is the power it's using for vibration. We really have a nice set of crosshairs on it. So if we're looking at a pump curve, if you guys are familiar with that, just getting really techie with you here. If we're looking at a pump curve, we can now see where that pump curve adjusts with the VFD and with vibration. We can really tell you a lot about it, and then we'll actually schedule preventive maintenance against that pump when you should do it. So no more of this reactiveness. And that's kind of our thing. We're not always just basing it off of a schedule. And that's kind of our thing, right? Is like, why base it off a schedule? Why not maintain it when it needs to be maintained? Because if you're in an office area and maybe there's a lot of folks in one area, guess what? That air filter is going to get clogged up a heck of a lot faster with all the germs in the air. So
couple of things, Alex, let's like to interrupt, but we saw a couple of questions coming in, and we definitely just wanted to let everyone know we'll answer them if they're part of what we're talking about at the time, or if not, we will be sure to answer all questions at the end. So just hold them tight. And in the meantime, also one thing I wanted to explain about your solution, which I think is pretty cool, is you have the technician or whoever it is install it And as soon as that device is connected to the internet that you've previously discussed, it'll call them and tell them that everything is connected, everything is working. That so in essentially they'll get a kit, physical kit from TDO, wire it, and if it's done right, they'll know it right away because they're receiving phone calls telling them everything's okay. And then we're off to all the solutions that you're talking about.
Yes, yeah, thank you for that, Renee. I forgot about that. And don't worry about interrupting me, please. I'm married with kids. You know, I'm interrupted all the time. I'm full of terrible dad jokes too. By the way, throughout this conversation, if you guys are interested. So that is a very critical piece, by the way, that you mentioned. And it happens in two ways. So it's upon the initial connection where people are like, hey, I'm connected. I'm great. Fantastic. Guess what? When the device loses connectivity, it also makes a phone call or text message to the people that you choose in the system. We've actually used this to find out, hey, a building's out of power or if we've lost internet in the building. People rely on that one simple service for that. And guess what? Unlike a security system that does a ping maybe once a day, we give it 1 minute. I could make it as aggressive as 5 seconds or 1 second, but we choose against it because there's a lot of network flutter that we've learned. So we said we're going to give you 1 minute because maybe you disconnected and you'll reconnect. We don't want to keep pinging you to say, hey, your network's not that ain't doing so hot, right? On the right side here, we see this ask your building a question. This is an additional AI model that we did. And what it does is we combine all of these modules into one where you could start asking natural language questions. And you're going to see some live demos of that with Rio data from their ICTD temperature sensors to some of the pump data. You're going to see a bunch of stuff. All right.
One of the things I wanted to say is one of the best things about this webinar and getting Alex and I together is I feel that we both have a good skill at being able to take some very technical topics and explaining them on terms that you don't necessarily need to be from the industry to understand them. So with his PhD software expertise, being able to explain that he can analyze all this data, put all the software inside the Opto to get you all these analytics. That's where we're in the process. We're right now taking our learning center, putting his software inside so people can have a suitcase and take it around their building, wire it with the little square black sensor that he held up, and that's already sending you information to do those analysis. So just mainly is just to give you that comfort level of reaching out today. Tomorrow you'll have plenty of phone numbers and emails to contact, but we're in the business of making this very practical for your facility. So I'll let Alex take it back.
Thank you. And I will say, working with Opto has been fantastic. I've been working with you guys for years. We have a great relationship. I call Renee's cell phone and he actually answers the phone. It could be on a Saturday or Sunday. Hey, I got this quick question. I know some of the folks on the line from Opto I've called you too, so I apologize for the weekends because for me, every day is a Monday. So, all right. So let's go through some of like the solution, a little bit more of the process. And you're very familiar with this. So an issue for us either found, sensed, or predicted. Once we get that, we push that note to the cloud. And then once we have it on the cloud, and this is not including the analytics are always being pushed up behind the scenes. So this is when we found something major. We need to make a phone call. We need to do something. So we determine how we need to broadcast that alert. So you can pick and choose like, hey, I want a text message or I want a phone call. I want both. I want an email or you want to generate a work order, or it could be for preventive maintenance too. Once we do that, and this can go across your organization or including your vendors. Our style is like everyone who needs to know should know, right? This eliminates the need completely of playing the game, telephone, and texting everyone, hey, did you see this? Hey, did you see that? Right? Gets rid of it altogether. Once the system realizes that the change of state is back into the normal state, and I'm going to give a great example of this right after this, what happens is whatever mechanism you got, so maybe you got a phone call to say that this alert has occurred, once it's self-resolved, you'll get another phone call say, hey, this result has been completed, but we also capture duration. The duration of that alert is so critical because guess what? Let's talk about this in detail. So we have this alert and it's on a certain asset. And with that asset, we know all the asset details of it. Remember when I was talking about you looking at the full history of that, like, hey, when should we take action of an asset? Like this is where it counts, right? So if I look at that RTU from McDonald's, I now have history against that asset to say, here's all the failures that occurred for this amount of time. So chances are, if another alert's going to happen, it's going to be this, because these are the symptoms that created the previous one. And this is generally how long it lasts for, because we have data that proves it. And by the way, every asset, as works independent of each other. We've got those 5 pumps we talked about with that 23 building story. Like, every pump's going to act completely different. Could be the exact same 60 horsepower pump. Doesn't matter. The physics that feed that pump and the components inside that are manufactured, they're all at different levels, right? Okay. This is one of my favorite slides. I call it, predictive maintenance for pumps detailed. Sure, it's really the need, why you need predictive maintenance. Okay, so let's pretend we're in your organization. We're looking at one of your pumps. Okay, we put a simple vibration sensor. Maybe you're just looking at one property. You're just looking at vibration of the x-axis. This little guy I was showing Rene earlier, we're getting about 40 different properties out of this one that we're measuring and monitoring. But let's just pretend we're just looking at one axis, the x-axis for now, right? So we're looking at it going left and right from a vibration standpoint. What we have here is a pump that looks like, with these sawtooth horns, what it's telling me, it's short cycling, right? It's on and then it's off, and then it's on and then it's off. That's really bad behaviors of an electrical component. If this was hooked up to a traditional system that didn't have machine learning built in, what would happen is, based off this red line here that indicates an ISO standard, I'd get an alert here and here. That's it. But in reality, this device keeps short cycling. We found this information. We set up for this organization to say, hey, I want you to send out an alert, is a text message to say you're having some really weird behavior of this pump. And guess what? We knew the pump history. We have the data of it. We actually said it was short cycling because it was turning on and off, because we could detect it. So we actually said to them, these are the possible probable causes, because ourselves, with the Ask Your Building a Question, has a large language model that will narrate probable causes with you. Hopefully that sentence makes sense, because that was a loaded sentence. All right. With this information, we took that to the manufacturer and said, send us a new pump. Absolutely did. 4-month-old pump. So that is what I call the need for predictive maintenance. And that was with that sensor. But I'm going to even make a simpler example using all Rio hardware. So this was in a school. We had a Rio hardware box, and we were using Rio's Opto 22's ICTT temperature sensor. And the way that it was working, and I've got slides to show these things, but I wanted to talk through it first because I'm so excited, as you can see, right? The way that it worked is that the condenser in the freezer is for a walk-in freezer that once it hit 32 degrees Fahrenheit, it had to turn on and cool to -2. That was the pattern. So I'm at 32, got to turn on. I'm going to get down to -2, then I'm going to shut off. This is an older unit. And it was rinse and repeat, rinse and repeat. This facility for the walk-in, it's right next to a cafeteria where it got really warm. So it was constantly going up fairly quickly. People opened doors, so on and so forth, except for the weekends, right? So there's a pattern there that I just described, right? Our system on the Rio figured out that it was hanging out at 30 degrees. So the condenser was on. It was trying to cool, but it couldn't. It just was hanging out at 30 degrees. In terms of a BAS or a BMS system, you're still within the realms of being okay. You're not alerted yet. Our system saw that and said, this is an irregular pattern. I'm going to text you this issue, right? It kind of sounds like a little bit like Skynet for Terminator, right? We're not super there yet. So it sent out that message to the facility manager and the head of the culinary, because it knows who should be informed of these types of issues from our system. Once they received the message, they're like, oh, that's weird. No one's there. This was a Saturday afternoon at 2 p.m. What did they do? They came in. We gave probable causes. We said the system thought it was a Freon leak because that's one of the scenarios that could occur. Turned out it was. We bought them an additional 8 hours until the food started getting above 32 degrees. So talk about being nice and relaxed. You've got 8 hours to solve this problem. Take your time. You're not going to be rushing here. You can move that food over, which typically, by the way, a walk-in freezer typically has anywhere between $25,000 to $35,000 at any given moment. You're not making emergency calls. You're not doing this. You have time to relax and breathe. Okay? And that's just with a simple ICTT temperature sensor and a Rio, and of course, our software on top of it. Next slide here. It's just, we do have a mobile app. This is more focused for work orders and checklists, so don't worry about this too much. We do a lot of custom analytics, and this is, every organization's a little bit different. And Rene's showing his right now with McDonald's right there. Oh, so fancy. We're going to show some other stuff too. This was just looking at some temperature stuff, some pump analysis. We're going to show a live demo of this, water flow usage, so on and so forth. Next is actually with an EMU. We did a case study against a freezer looking at heat maps. The idea is to say we can kind of generate any type of analytic BI system you're looking for. It just really depends what you want, because every organization, as I said at the beginning, everyone's different, everyone's unique. No two assets even act the same. This is just a quick map view of what we have, but you know what? I'm going to go pull up the website now. Can you guys see my website now?
Yes. Yeah. Ask your building a question at the top.
Do I need to zoom in?
I don't think so. It couldn't hurt.
All right, let's zoom in just a hair. There we go.
That's good. That was great.
What we're viewing now is an instance of True Data Ops, and I've got 4 different versions up here. And I'm going to go as quick as I can through these. And what we're going to do is I'm going to kind of explain the organization, what they're doing with Rio hardware, with Rio and sensors and so. And then I'm going to ask some blatant questions about using the Ask Your Building a Question and see what comes up. So this is an organization. They have boilers from the 1960s, temperature sensors. They got pumps. They've got energy from the EMUs. I mean, they got literally everything, you know? So I'm going to ask a very simple question. With my current alerts, what insights, I can't spell, do you see? So insights, I teach an AI class for facility management. I fly all over the country for it. And I always tell everyone, I was like, if you want your large language model to get an idea of anything, I was like, you should use the word insights, where it tells you things. You don't have to worry about it, right? You're not giving it any kind of thoughts. You're trying to tell it, like, you tell me what you see, right? So here we go. So we can see a return fairly quickly. So we see pump vibration data. Hey, that's the name of the asset, P15A. There's a lot of alerts here because the average value is at 12.26. The max duration of them, and so on and so forth. Then we can look at the freezer temperatures versus the culinary. You see that there's been 93. The average temperature is at 42. The duration is about 35.5 minutes. Culinary, so on and so forth. If we scroll down here, we can actually get some recommendations. There's a mechanical failure risk. About it and repair any freezer issues and so on. And pretty cool stuff. I know I'm going through this really quickly, and that's okay because we got some other fun stuff to show too. And by the way, this is the web application. We do have a mobile app. And on the last tab, I have a little bit of a surprise. So the next one is actually the McDonald's data. I said with my current energy management of the last year, so pull in the last year's worth of data at 1515 Euclid Ave, what insights do you see? So you can see some initial increase with the spring. We can see some cost here, some power quality metrics, and this is where I kind of want to spend more time on because this is really where the EMU kind of shines, if you will. So we can see that the power factor is mostly low, between 0.3 to 0.5 throughout this period. And we're telling you a healthy power factor is greater than 0.90. So here's the best part with TDO with this case. I'm dangerous with energy data, but let's pretend I'm not an energy manager. Hey, I see this value, but now I'm telling you also that the power factor should be above this. And I can tell you from a cost perspective, they're probably gonna there's a cost associated with that for where they are. So we're telling you, you can see it right there. You're probably billed for your low power factor and wasted energy. So what do you do with this, right? There'll be suggestions down below, but now we're trying to tell you, hey, things are happening. There's problems here. You may think that your asset is working correctly, but in reality, it's kind of struggling a little. We can see some peak demands, and now we can look at opportunities and recommendations. Your power factor is constantly low. Install power factor correction equipment like capacitor banks or investigate large inductive loads, so on and so forth. Why? Here's why. And then you can check if your low power factors could be significant. Some demand management stuff. Look at all this stuff. It's pretty interesting, right?
So a couple of the low hanging fruit there would be to track down what that power factor is by just turning some things off and on and doing a quick replacement. And that should that could possibly reveal something right away that they can fix.
Right. Kind of looking at another institution here. Now, this institution has an EMU, and they just wanted very specific data. So I just clicked on the analytics. They also have 4 temperature sensors from ICTD down below, but the top bar, all they cared about was kind of like a daily chart. This is connected to another school cafeteria, funny enough, and this is looking at their panel. They wanted to know their kWh consumption during the day and how much it was costing them. But then on the right side, they wanted a table, and I can adjust this to the last 30 days.
Yeah. So what is that table? That's how much it's costing me per hour
This is
per
the day.
day.
Yep, the daily cost, the monthly cost, the kW peak. So let's find out the highest cost day was $56 over the last 30 days on 4/15, right? So from 5/6 to 4/6, we analyze that data. Now, if we look
The
at
data is the same. You have it trended on the left, and on the right, you can
yep,
massage it and look at it per day or per
yep.
amount or
And the
peak.
and the yep. And here's where it gets kind of interesting. We can actually say with that let's look at the kW peak instead. So the biggest peak was on April 15th at 3 o'clock in the afternoon. So now you can look at it from different perspectives in this simple table. What time was the biggest peak? Because there is demand charges, as everyone knows. What time of the day was it, and at what time? And then we could see the next instance was right below that. Or we could say, what was the highest daily cost? Well, guess what? Happened to also be the 15th, which makes sense with the peak demand in that case. Make sense? Or I can start looking at this and say, hey, look, freezer 1 over here was at 57 degrees. Let me just highlight over this area to kind of zoom into the data because they're all related to each other. Let me keep zooming in. We can see this peak. I bet you there was a really big delivery because we can see it cooled off pretty quickly. Someone forgot to leave that door wide open. I'm sure they got phone calls with this alert. All right.
Just trying to look at the day of the week of each of those days. There were a lot of Wednesdays, so I wonder if one of their scheduled delivery days is a Wednesday.
It probably. And now but kind of my last thing, because I really do want to open up to a Q&A, is kind of like, where's the future of where we're going? And this button right here is one of the fun buttons here. It's like party mode, but except it's dark mode. So I don't know if you guys are a big fan of dark mode or not. I'm not a dark mode guy, but I know a lot of the people in the call probably are. So I'm going to hang out in dark mode for this. But this is what we're calling like the future of analytics. This is what TDO views of like, where is everyone going, right? What makes most sense? So this is a scenario. I'll shut off work orders for now, where we can look at, say, sensors and energy, and how do we organize everything that you have? Because that's a huge problem, right? You may have 100,000 points, right? Because the examples I showed you were very simple, and those were done purposely. We do have much more elaborate examples, but I try to keep it simple for these types of webinars. So let me show you a way that I've got, 420 temperature sensors, 180 humidity sensors, so on and so forth at different types. Like, what do you do with all this data, right? Your typical BAS system. So this is kind of the idea that we're getting with it. I just wanted to kind of share it with you. Looking at AI insights to kind of give you ideas. What are we seeing things on? Some flow rates, so on and so forth. And then you can look at all your sensors independently. Or the cool thing is actually with energy, in my perspective, you can start now looking at usages and cost, the peak demand, today's usage patterns, 6-month trends. Where are they coming from? What's the health of them? So it's really trying to give you some insights really quick, right? Where do I go? Some unusual consumption patterns. It's very visually appealing. Where can we do energy benchmarks, saving opportunities? This is consumption time of day versus use of day, which I know are completely different things. And this is kind of where we're going with, because you may not be an energy guy, but we're trying to help you understand it. Everyone understands dollars and cents, so why don't we help relate that to you? And this is all based off a static KW cost, just so everyone knows, right? With this data, cost trend analysis, some asset health, because remember, If we know what the asset is, we can really give some insights against it. You kind of saw that with the Ask Your Building a Question and so on. So you could be a main distribution panel. That's fine with us. Some active and low. Just I'm flying through this stuff, everyone. So don't mind me. All right. So I think that's really about it that I have. It's 2:30 on the dot on our time. I wanted to answer some questions. So Rene, I'm trying to see
Yeah,
where
we have. Yeah, no, they could go ahead and type in some questions if you have them. If not, I have some for you. And also, do you have any pictures of the install you did at that you're doing at that 23-story building? Not
uh,
I, not I have one.
do you
You
have
texted me. Yeah,
I did.
I'll get that going here. And also in the chat, I put the TDO Connect brochure that explains what we just went over in a very quick 1, 2, 3. We need your facility, you need an Opto 22 device, and then you have your TDO Connect um, software. So let me show that here. So this is it, I believe. Whoops. There we go.
Let me stop sharing.
This is it, I believe.
Yep. So that's an example right there of it. So if we
So you can see the TDO box there. So this is the unit that you installed with the light on it.
and you can see the groove
light-
aspect on the bottom right.
Yeah. So there, the logo there. And it looks like here's your sensor.
Yep, the sensor is right there on top of that casing right there.
How'd you mount that?
It's magnetic. So it's a pretty easy install. So that's a mod bus. So we've actually connected 5 of them all into one line, into one using your USB to serial device that you guys recommend. It all wired up through that box right there. And then it went right in and we fit it into a fairly sized room. The idea is that we have a green, yellow, red light. Sorry. Green means that I'm connected and everything looks good. Yellow means we're finding a fault, but don't be too alarmed. And then red means we have found an alert and a fault, and we're just trying to get your attention. So the idea is that not everyone may have access to TDO, but everyone knows that red light means bad if they usually see a green light. So they're going to go tell someone. That has been so prominent. We do that a lot with even the walk-in refrigerations, that we know that not everyone has access to it, but if they see a red light, they know to go up to that door and make sure it's shut, because we know we're out of range. That's been a real quick one.
Okay, so go ahead. Looks like we have a few questions now. Let me start off with the one I saw from RC. It's like, how can you use the connected equipment for energy forecast to minimize your demand peaks?
Sorry, where is that? Is that in the Q&A or in the
That's in the chat. So we're having questions coming from 2 places, on the chat, on the Q&A. So whichever one you find first and wish to answer first.
Yeah, let me just try to bring them up. I am not a... Okay, how can you use... This is from Richard. How can you use connected equipment for energy forecasting so minimize your demand peaks? Great. So, Richard, here's what I would say to you for that. And I'm not looking away. I'm just looking at the question. Is this energy connected? So we would install an EMU on that device, okay? So we can get the energy consumption out of it, so we can understand peak loads and stuff like that. If it's by itself and we're not connecting via any integration points, we would then say, okay, let's tie this back in with your GPS location, because we know where you are, we know where that asset is, and we'd also grab the outside weather. By the way, NOAA, NOAA, if you're not grabbing NOAA weather, it's free. It's from the government. If you're in the United States, it's a fantastic resource to get weather from. We back those two together. And then what we'll do is basically say, looking at your current scenarios of energy usage, we'll probably work with your energy provider, because we have plenty of conversations with them, and say, are you guys part of demand response or not? Right. And then what we'll also look at, depending on your asset, let's assume it's an RTU and you have a bunch of them. We'll also say, give me your backnet schedule of them, and then we'll tie the two together. Here's the thing, right? And hopefully I'm answering this, Richard. With an RTU, you could have 60 on a roof. If all 60 are turning on at 6 a.m. in the morning, like, there's your demand peak right there at 6 a.m. because it takes a lot of energy to turn them all on. The obvious answer is to offset them, right? And that's great. You could do that once, but with the emus, we're constantly scanning them to say, hey, there's this thing called retro commissioning. These things will go back to 6 a.m. because there'll be an override after 3 months because someone forgot about it, right? And that's what we're kind of looking at. So you can take an action such as moving these patterns. We're able to monitor it, every 5 minutes or so. We're pushing that data up to our cloud for analysis, but internally it's happening a lot sooner. And then from there, we can start giving out recommendations. If you give me some examples, maybe on the side, if you want to email me like what type of assets you're more concerned about, I can give you a better strategy for sure. But the simplest one with RTUs is basically like we typically go in if there's like 40 of them or 60 of them, like you're probably all turning on at the same time because you're trying to cool this building before people actually enter the building. Maybe you should start at 3 a.m. As crazy as that sounds, just because your demand costs are really high. And the only way to really get there is by talking with your energy provider and looking at some of your bills, and then putting the emus or the epics the with the energy monitoring on top of that to really have an understanding of where everything's going. Because if you cannot measure it, you cannot manage it. Okay, Victor. So is that vibration sensor a commercial one? Do you have a preferred energy measurement device? So if the energy measurement device you're referring to is the vibration sensor, we actually was recommended. We've used a few of them actually recommended from Opto. So this one right here is from IFM. If you're happy with that one, and this one's a banner one. I've used both. I don't want to
Talk to all. Yeah.
So,
but you really like that banner one though.
I do. It's newer because there's some other tricks up it. Because again, I'm a computer scientist, so I'm very comfortable about doing some of the manipulations with it.
And when you were showing there were like 30 data points coming from that one, when I thought it was just going to give you 3 vibrations because it went for each axis. Yeah.
Yeah. No, there's about like 30 data points. Some of them we actually generate and calculate and derive off of that. And here, it's the Opto 22 emus for the energy for the KW stuff.
So it looks like this. It's at the front terminals a little different. And
next,
yeah, we had another question too about time of use pricing, and yes, that's something that you were saying you work with the provider of energy to figure out what those are and add those calcs, so adding into the formula.
Yeah, so the energy providers I work with, I've got pilots with a lot of them, and I do ask them for time of use patterns. Like, do they have them? Are they publicly displayed and stuff like that? Because the relationship that we have, we try to feel like we're an extension of your organization, not just coming in there and saying, oh, here you go, you're done, you're all set. It's like, yeah, no, that ain't gonna work too well. We always want to be part of those conversations. And we always give a plan to say, this is the plan and here's why it works. So whoever asks about time of use, we do ask the energy provider. And then what we do is we actually have a little page that we set it up. So we know that this asset that has this emu connected to it has this time of use calculated. So we know what your KW is for that. And it will adjust automatically as an algorithm.
Wonderful. Looks like we have a few questions here. Seem to be a little bit related. So I guess we should explain a little bit more clearly of what that architecture is. So the architecture is, depending on the physical device, that'll be the sensor. If it's energy, it'll be an emu. If it's rotary equipment, it's going to be one of those axis, like possibly one of those banner 3-axis sensors. And all of that goes into TDO software that's literally running inside the Rio device. So your TDO software is running in this unit. Not only that, but also you have WireGuard and several other Dockerized systems running in here. So you have all of it running and edge in this edge device. And from that, then transmitting that information to your TDO cloud service. The question is how to get this provision with an Opto 22 SCADA or with any SCADA. And this just goes down to, the more working in facilities, the more I'm finding out all these gigantic companies have these huge BMS systems. And in a lot of cases, the BMS systems is just to help provide a little bit more data to the people coming in, doing the work and doing the maintenance. So they're not even using it on a day-to-day basis. But I digress a little bit from that, but just wanted to state that for this is a plug and play simple solution. Hardware goes in, the TDO is already inside it. So that's how it knows to connect. the TDO website is where you have all this data going on. If you want then to output it to a SCADA system, you merely just need to tell Alex, I'm using this. Could be, I'm using Ignition and I'd like to have it served up to this broker. I'm using this other SCADA software and I want to talk to an OPC UA. By that point, the data is already in the TDO ecosystem. It's merely a matter of how you wish that interface. So it'll be case by case, like Alex said. You could have 3 different schools doing this. You could have 5 different schools doing 5 different doing 5 of the same thing, 5 completely different ways. So in that, some of them will have different SCADA systems as well. So to answer your question, this is TDO software inside the Opto hardware. And from that, you choose Rio 2 or EMU or even an Epic. You'll get the sensors that you want with that hardware, with that software, and a TDO. You'll get a TDO login to be able to see that. So let me show you what my TDO login looks like, actually. And we could go from there. I think with that, if there are any more questions, we're going to start to wrap it up as well. All I need to do is remember my password, which could be its own. Okay, look at that. So here, for example, so I have my TDO login, and here I would have different customers that I work with or different facilities, and that same Ask Your Building a Question is already built into it. So I could have things like my different analytics for, let's say, different energy management that I'm looking at. So let me look at the last 2 months here. So this is a login that I didn't have to create. I didn't have to do conversations with Alex to create what those templates are going to be, to create those charts of how much it's going to cost me per day. And also could look at different, let's say, what is it? Inventory management? I forgot how it is. What is it? Assets. Here's live tech support.
Go to browse by location. Oh, you can type in RT.
There we go. So here we have for that rooftop unit, we'll have the faceplate for it, all the different information of what the statistics on it are, last time it was serviced. So this is all created after the TDO box has already been put in on site and wired. Then your technician or just any licensed electrician could go in, wiring it, follow the instructions, and this page becomes more alive as you're adding more of those hardware units to it and integrating to Schneider BMS, Johnson BMS. I mean,
and
Ignition, you name it.
Yeah, one thing that we do that's really cool too is that we'll take IoT devices and also convert them into BACnet data points or SCADA point, if it makes sense, right? We can convert it over. So we'll take things that don't naturally speak a certain thing, like taking the ICTD temperature sensor, and now it's a BACnet data point that we have some BMS systems also pulling in addition to ours. So it's really, as I said, everyone works a little bit different. So we just want to make sure that we understand what your needs are. And our big thing is trying to like, hey, we're going to send you this box. It just magically works. We talk through the process because we've had plenty of great conversations ahead of time. So we know what it looks like. So once you plug it in, connect the sensors, it just kind of works. And you get a phone call when it's connected.
So for example, this customer wanted, I want how much it's costing me per day in a trend. They didn't want a chart. And I want to see in a trend what my calendar month energy consumption looks like, as well as my billing month looks like. And from these, you have the 3 emus that are in that location. You can see by the day how they're using that and how they're using that. And this is what helped us to determine for them. They thought, like you said before, Alex, they thought 80% of their energy usage was in the rooftop units, and it proved to be a lot less than that. So we were able to now target and focus more on refrigeration systems and find out that several of the cooking equipment, which were originally detailed as being gas, some of them being heavy electrical and constantly on as well.
Gigantic resistors.
Gigantic resistors, yeah.
Yeah. Sudar asked another question. How does TDO talk to the groove? Sudar, could I ask a clarifying question for you with the groove? When you say groove, what part are you referring to? I just want to make sure you and I are on the same page because we'll talk to the IO pins and all that stuff. If you're referring to that, it's actually via Opto 22's APIs to pull that data. So if we're pulling it in, if it's on their USB, we have a driver that we built, they'll connect with it. But if it's upon their IO pins that you see,
Controller.
the controller pin, we'll pull it directly from their AI, from their API. So yeah, that I'm assuming would be the API then, yeah, because it's literally running right on there. It's
Yeah,
really
you should add a TDO logo right here for this presentation. Should have done that.
yeah. So to give an idea, right? So we're communicating with the Groove Manage, right? That's your API that we shut off Node-RED. We're not, we're using Modbus to connect if it's via USB. We don't use Sparkplug. We do have our own custom MQTT stuff, and we don't have Ignition on for our instances to really clarify, hopefully. And then where this is going up, it's actually going into the TDO cloud.
On this one, and we'll make this one the last question. Although it's a great one, so we definitely don't want to gloss over it. But time-wise, go ahead and answer on cybersecurity.
Yep. So ours is probably triple secured over because we use MQTT with our own certs that we manage and we allow. So no one has access to it at all, period. So only we have those keys that are on the device that you cannot get access to. No one can. And that's the way we do it via TLS 1.2. And we have a 256 key bit encryption that goes along with it. And then when we send messages back, there's actually another triple layer of encryption that we put in there. And there's a special pass that goes into it. It's a real fun whiteboard example to go through, but that's the way that we do it. It's not just username, password. We don't believe in those.
Yeah.
When it comes
into so one of the main points of this is just that we're going to put our contact information in this, share it with everyone. Just reach out. We can quickly put together what a proposal would look like for you. And I mean, just to leave people with some kind of idea what ballpark pricing you're looking at for one of these, what will we be looking at for a proof of concept price, Alex? Let's say one of these devices, for them to try out, and just like we left in the flyer, you'd have this, they'd have the sensors for it, they'd have a description of how to wire it and plug it in, and a login from you. What would they be looking at?
Yeah, sure. So we sell an EMU kit. So that would be, for 3 CTs, like such. You can see that. Up to 400 amps. We sell that with a year's license of TDO for 1,500. Sorry, for $5,000. The license is 1,500 annual after that. So it's not too much to find out how much, energy you're using. If we need to use like a row coil for something else, the price just goes up slightly just because the coil price is much more.
Yeah.
So it's really not that bad just to find out how well your building is performing. And that's usually where we start. We don't recommend boiling an ocean. We try to start with a small project, get you comfortable, show you that instant ROI, and then we build it in such a way that it's ready for scale immediately. We don't have to go keep sending you more hardware. That's the big thing.
So I'm glad we have one quick last question. Or RC's asking, the analytics, do they happen inside the Rio or in the cloud?
Cloud.
And I think there you go. Now, they could happen in the device if you needed them to, but
yeah, we have very long storage in the cloud with it. That's why.
Yeah. All right. So with that, I'd like to thank Alex. I'd like to thank all of you for attending. Thank you, True Data Ops. We'll follow up with a link to this video, as well as link to everyone's contact information. Happy to dive into how this can work for you, whether you're looking at that suitcase to monitor different items in your building, integrating 2 different building management systems. Maybe your building management system bill is coming up in 4 months, and you're looking at that software bill and thinking there's got to be a better way, and there is. So hope that you will reach out to us then. All right. Any last words, Alex, before we hang up this time?
No, thank you. Thanks for having me. It was a great time.
Yeah. All right. Thanks, everyone. Have a good day.